Yes, welcome you all again. We're continuing this important question series. Today we'll be talking about the friction. Friction and types of friction and angle of friction and angle of repose. Now, first of all, let us discuss friction. Friction is a contact force. There are two types of forces. One is field force, another is contact force. Friction is when two bodies are in contact. जब एक अगर यहाँ सरफेस को ये मानते हैं और यहाँ ब्लॉक मानते हैं आप मास m और हम यहाँ से अप्लाई करते हैं फोर्स F, then there is a contact between the surface and the another body. Or when two bodies are in contact, then there is a relative motion between the two bodies. When two bodies are in contact, then there is a relative motion between the two bodies. At that very moment, friction comes into play. The friction plays a very important role in our day-to-day life. Friction is actually an opposing force. ये एक opposite force है. The way resistance opposes the electric current, viscosity opposes the fluid motion. Similarly, friction opposes the mechanical force. It opposes the mechanics of a body, motion of a body. When a body is in motion, the friction opposes its motion. This friction comes into play when two bodies are in contact with one another. That is, there is a relative motion between the two bodies. So we take the friction into consideration. So if it's a rough surface and you have a body of mass m, then there is an applied force. A frictional force comes into play in this direction. A frictional force that is tangential to the surface of the body. That frictional force is tangentially to the surface of body, or you can say that is parallel to the surface of body, and this frictional force F opposes the applied force. But that is in terms of, we can say this is in terms of following the Newton's third law, that to every reaction there is equal opposite reaction. The more you apply the force you apply here, there comes into play a frictional force that is in opposite direction and tangential to the surface, or you can say parallel to the surface in opposite direction. So this is a friction, this is opposite to the applied force. Friction जो है ये motion में भी होती है when the body is in motion or when body is at rest. Rest के time जो motion friction होती है, that is a static friction. Static friction. और motion के time पे जो friction होती है, that's called kinetic friction. The types of frictions. जब body motion में होगी तो उस समय जो friction होगी, that is a kinetic friction. Kinetic stands for body is in motion. And when body is at rest, उस समय जो body friction produce करेगी, that is called static friction. There's the two types, static and kinetic. The maximum value of static friction. अगर मैं F से relate कर रहा हूँ static friction, F maximum. Static friction का maximum value gives a limiting friction. ऐसे याद रख सकते हैं. There's a types of friction. One is that body is in motion, you have a kinetic friction. Body is at rest, you have a static friction. But the maximum value the static friction can have, the maximum value Fs max of the static friction is known as limiting friction. Now we can explain it, what actually it means. Suppose it's a body of mass m and you are applying the force F. This body is not moving. You are applying force. Although, जब आपने F apply किया, according to Newton's law, when you apply the F is equal to ma, there must be an acceleration F by m. The object must move with an acceleration F by m, according to Newton's second law. But this body is not moving. So, because this is producing a static friction. It has a static friction. But a time reaches when you apply the F, the static friction also increases. With increase in F, your static friction also increases. But a stage reaches where static friction is maximum and this body starts to move, this body tends to move or starts to move, known as limiting friction. You can say the maximum value of static friction is known as limiting friction, and limiting friction, the body is at the verge of motion. That means now it tends to move, now it tries to move. So the static friction, you can write that F maximum or limiting friction, F maximum or limiting friction is directly proportional. You can say the F static or F maximum is known as limiting friction. So there are three types. You can have a friction. The friction is three types: kinetic, static friction, and the maximum value of static friction is known as limiting friction. This F static is known as Fs, limiting is known as Fl or F maximum S, and kinetic is known as Fk. These are three symbols. The force which comes into play when two bodies are in contact with one another, the relative motion causes a force, opposite force known as friction, or friction is the opposite force, is a force which tries to seize the motion of the body when it is moving in forward direction or whatever the direction is. So applied force को जब हम किसी सरफेस के साथ कांटेक्ट करते हैं, वहाँ पे जो फोर्स आ जाएगा, जो अपोज करेगा टेंजेंशियली टू द सरफेस और पैरेलल टू द सरफेस, इज नोन एज फ्रिक्शनल फोर्स. और फ्रिक्शनल फोर्स के पास हमारे जो टाइप्स है, दैट इज काइनेटिक फ्रिक्शन, दैट्स व्हेन द ऑब्जेक्ट इज इन मोशन. स्टैटिक फ्रिक्शन व्हेन ऑब्जेक्ट इज एट रेस्ट. बट द मैक्सिमम वैल्यू ऑफ स्टैटिक फ्रिक्शन इज नोन एज लिमिटिंग फ्रिक्शन. यानी कि अगर आपका ऑब्जेक्ट है, सपोज मैं फिर से एक एग्जांपल कोट कर रहा हूँ लिमिटिंग फ्रिक्शन के लिए, कि अगर आपका ऑब्जेक्ट यहाँ पे 10 न्यूटन फोर्स प्रोड्यूस कर रहा है, सपोज 10 न्यूटन इसका है, 10 kg इसका वेट है, और आप फोर्स दे रहे हो, सपोज आपको 10 न्यूटन फोर्स चाहिए इसको मूव करने के लिए, तो आप 8 दे रहे हो, 8 न्यूटन, ये बॉडी मूव नहीं कर रही है. आप 9 न्यूटन दे देंगे, ये बॉडी बिल्कुल मूव नहीं करेगी. आप 9.99 दे दें, कुछ नहीं करेगा मूव. लेकिन जब आप 10 न्यूटन दे दें, नाउ दिस बॉडी इज एट द वर्ज ऑफ मोशन. तो दिस यहां तक 1 2 3 4 up to 10, it is adjusting its opposite force called self-adjusting force. This self-adjusting force or variable force, जो static friction है, it's a variable force or a self-adjusting force. ये अपने आप को तब तक मेंटेन करेगा, मूव नहीं करेगा जब तक ना आपका जो applied force है, F applied, वो greater हो जाएगा, और your F will be greater than static friction. This maximum force when body is at the verge of motion, that maximum static friction is called a limiting friction. तो आपको 10 से you must have a force greater than 10 Newton. So when the force is greater than 10 Newton, then object can move. It will start to move, becomes a limiting friction. And then when object is in motion, that friction that will time is a kinetic friction. So before going to discuss again, when two bodies are in contact, say it's a rough surface, इसके ऊपर एक ऑब्जेक्ट है, ब्लॉक ऑफ मास m. This m will have a weight mg डाउनवर्ड डायरेक्शन. और यहां पे एक और फोर्स आता है, this mg, this surface will have equal and opposite force in upward direction called normal reaction n. तो कॉन्टैक्ट फोर्स में आपका एक फ्रिक्शनल फोर्स आता है और दूसरा नॉर्मल रिएक्शन आता है. नॉर्मल रिएक्शन आपका mg को अपोजिट होता है, और फ्रिक्शनल फोर्स आपका वो जो होता है, फ्रिक्शनल फोर्स अप्लाइड फोर्स की होता है. ये अप्लाइड फोर्स इस डायरेक्शन में है, तो फ्रिक्शनल फोर्स इस डायरेक्शन में होता है. वो एट इक्विलिब्रियम, your F is equal to this F, your frictional force is equal to applied force, and your normal reaction is equal to mg. Normal reaction is equal to mg. कोई भी अगर आप ये चौक हाथ पे रखेंगे तो यहाँ नीचे की तरफ चाक का mg होगा वेट, और मेरा हाथ जो है वो इक्वल फोर्स चाक के ऊपर डायरेक्शन में अप्लाई करेगा. दैट्स कॉल्ड नॉर्मल रिएक्शन. नॉर्मल मीन्स परपेंडिकुलर, रिएक्शन मीन्स अगेंस्ट दिस mg द फोर्स एज पर न्यूटन्स थर्ड लॉ. सो अगर ऑब्जेक्ट ऐसे होगा, सपोज ऑब्जेक्ट इज लाइक दिस इंक्लाइंड, तो इसका mg नीचे होगा, लेकिन जो नॉर्मल रिएक्शन होगा वो सरफेस पे परपेंडिकुलर होगा. सरफेस पे वो परपेंडिकुलर, ये सरफेस है, इंक्लाइंड प्लेन पे इस पे परपेंडिकुलर होगा। अगर आपका सरफेस ऐसे है, नॉर्मल रिएक्शन ऐसे होगा, mg ऐसे होगा। अगर आपका सरफेस ऐसे है, नॉर्मल रिएक्शन ऐसे होगा। तो जहां जहां पे सरफेस है, सरफेस को अगर आपको परपेंडिकुलर डालेंगे तो वो आपको नॉर्मल रिएक्शन की डायरेक्शन दे देगा। So the normal reaction is always perpendicular to surface. If you move this surface like this, the normal reaction will move करेगा. But this mg will be always towards the center of earth, that is downwards. So now, how to find out actual frictional force? आप frictional force को कैसे calculate करिए? You are not a direct formula. आप frictional force को normal reaction के साथ calculate करते हैं और normal reaction को mg से calculate करते हैं. Because you know m, you will multiply by g, you will get weight. That weight is opposite to normal reaction, you will get n. That n is related to frictional force, you will get f. So आपको इतना ही याद रखना है कि the frictional force is, there is no direct formula that you can calculate the frictional force. You calculate frictional force in terms of normal reaction, and normal reaction is opposite to the weight. Knowing the weight of the body, you can calculate n. Knowing n by another formula, you can calculate f. So that f is, the frictional force is directly proportional to normal reaction. The frictional force is directly proportional to normal reaction. So the frictional force is equal to mu times n. If I said the maximum static friction called limiting friction, then is a mu s, coefficient of friction. Let me write the journal. This mu is coefficient of friction. If I write f S maximum means maximum static friction called a limiting friction, then I write a mu S as coefficient of static friction. This is the formula. This is also a general formula. So similarly, if you have a kinetic friction, then F is directly proportional to N, then you have a coefficient of friction. F K is equal to mu K times the coefficient of kinetic friction. This coefficient of static friction here, this coefficient of kinetic friction here. So you just remember that friction is directly proportional to normal reaction. Friction is equal to mu n. For maximum this static friction, you have a static friction constant of proportionality mu n and n. This f, you can now what I was actually talking that how you calculate f. You calculate f in terms of mu n, and mu is given always in a numerical or in any problem. N is equal to mg. So you can write f is equal to mu mg. Knowing m, g is constant, mu is given, you can write f. So f has a formula, fs maximum, or simply frictional force is equal to mu times n, or fs maximum limiting friction is equal to mu s n. This is the formula. Now how to find the angle of friction? So you have a block of mass m. This is, I will draw the coordinate system. You see, along the downward direction is mg, parallel to opposite, equal and opposite is normal reaction. You have applied force in this direction and you have frictional force in this direction. You see, यहाँ पे मैंने एरो यहाँ पे डाल दिया, यहाँ पे मैंने एरो बीच में डाल दिया. हम अप्लाइड फोर्स बीच में अप्लाई करते हैं, किसी भी जगह अप्लाई करते हैं. लेकिन जो frictional force होगा, that is always tangential to the surface or parallel to the surface. That's why these arrows have they are anti-parallel arrows in the same, in opposite direction. But this arrow here indicates that is a tangential to the surface or parallel to the surface, and this one is applied anywhere on the surface of object or the block. So if you draw the coordinate system, then it will become origin. At equilibrium, your f is equal to f, your n is equal to n. So what I was talking about, how to calculate the f. You calculate f in terms of n is equal to mg. So if I compare these two vectors, then this will be the resultant as per law. This is the resultant, it making an angle theta. So I can draw the parallel this f here. So this you can write now, tan theta is equal to, from this triangle, right angle triangle, perpendicular upon base, that is n. So you have tan theta is equal to, you just calculate f is equal to mu n, and you can write f by n is equal to mu. So f by n के बदले आप mu लगाएंगे. So coefficient of friction is equal to angle of tan theta. So angle of tan theta, this theta is an angle of friction, tan inverse of mu is calculated. Likewise, this is simple so far. If I say a block of mass 2 kg हमें कितना फ्रिक्शनल फोर्स प्रोड्यूस करेगा और हमें कितना अप्लाइड फोर्स होना चाहिए ताकि ये ऑब्जेक्ट मूव करना शुरू करेगा. Suppose this is an object is a mass 2 kg, 2 into 10 becomes 20 Newton. So obviously normal reaction 20 Newton होगा. Suppose the coefficient of friction is equal to 0.3, then frictional force F, frictional force, say F is equal to mu times M, that's equal to mu is 0.3 into 20, you can write Newton, and you can write 3 divided by 10 into 20, 6 Newton. The force, the frictional force produced by this block is 6 Newton. So you must have a applied force greater than 6 Newton. Then object can move. So your value of applied force must be greater than 6 Newton because this block of mass 2 kg will not move if you apply the force of 5 Newton, 4 Newton, 3 Newton, 2 Newton, 1 Newton. Up to 6 Newton it will not move. Up to 6 Newton the object will not move. So if you apply 1 Newton, 2 Newton, the object will not move up to 6 Newton. But you will get the more than 6, the object starts moving. Its friction decreases and then it will move with the velocity that independent of the then it moves with a friction called the kinetic friction Fk. So this topmost point called F maximum as static friction, maximum value of static friction called a limiting friction, and this line is a limiting this is static friction Fs. This is maximum value and this is Fk. So the limiting friction has a maximum value than this kinetic friction. So आप ग्राफ देख लें, graph between frictional force and applied force. I just said with respect to this example, but यहाँ तक जितना force apply कर रहे हो फ्रिक्शनल फोर्स भी बढ़ रहा है, लेकिन एक स्टेज पहुंचेगा जब फ्रिक्शनल फोर्स मैक्सिमम होगा, उसके बाद नहीं बढ़ेगा, उसके बाद ऑब्जेक्ट विल स्टार्ट मूविंग और यहां तक ऑब्जेक्ट अपने आप को मेंटेन करेगा, मूव नहीं करेगा. That's called self adjusting force called static friction. और static friction is self adjusting force क्योंकि ऑब्जेक्ट मूव नहीं करेगा, खुद को वैरी करेगा, लेकिन एक स्टेज आएगा जब उसका फ्रिक्शन का वैल्यू मैक्सिमम होगा, दैट फ्रिक्शन का लिमिटिंग फ्रिक्शन, उसके बाद ऑब्जेक्ट मूव करना शुरू करेगा और जब ऑब्जेक्ट मूव करेगा तो उसका फ्रिक्शन कम हो जाएगा, तो काइनेटिक फ्रिक्शन का वैल्यू कम होता है एज कंपेयर टू लिमिटिंग फ्रिक्शन का वैल्यू.